Okay, so distributive property. Another thing, you've done distributive property. You should know how to do this. It should be a review. But most likely, just like a lot of this stuff, you're probably weaker than care to admit. So that's why it pays to practice it a little bit. I mean, next chapter, when we get on to pass this test, we're going to start solving equations. You know, we're going to spend a lot of time on solving equations because that is one thing that we all see as teachers when we're teaching Algebra 2 and higher that students really never learn very well. And what's that? Yeah, well, wherever you had it. To me, that's one of the things you should have gotten really, really well in Algebra 1. I mean, they should have taught you that to the point where you're really comfortable with solving any kind of equation, including if it's an equation that's got many variables in it. How do you solve for one variable when there's a whole bunch of variables out there? And we don't do that very well. You know, in the real world, you don't get equations that just have one variable in it. You just don't. I mean, there's no useful equation. It's just, here's an equation with one variable, solve for the variable. There's always multiple things going on. So, you know, the main thing about distributive property, and you've, like I say, you've done this before. This is their, you know, very theoretical example using all letters. These are the actual examples. You know, 4 times 20 plus 6 is 4 times 20 plus 4 times 6. And it doesn't matter if that 4 is on the left side of the parentheses or the right side of the parentheses. That's still a distributive property, right? You're still going to do the 20 times 4 plus 6 times 4. Right? So whether or not we show it on the left or on the right, that's how distributive property works. Right? 7 times 30 minus 2. 7 times 30 minus 7 times 2. So they give a couple examples. This is more looking at algebra kind of thing. 3 times x plus 8 is 3x plus 3 times 8, which is 3x plus 24. Or if you're multiplying from the left, 5b times negative 7, right, minus 5b, or minus 4 times negative 7. How would this one look, the letter A? 5x. Okay, say again, Andre. 5x. Not times. Not times. Plus 5 times 7, right? Which is 5x. This is a multiplication. Oops, I did that wrong. All right, 5x plus 35. How about this one? What will it look like on the first step? 12 times 3 minus 12 times 1/16, right? And the 12 times 3, that's one of our multiplication tables. 12 times 3, 36. Okay, now how do we simplify the 12 times 1/16? This is multiplying fractions. Yeah, if you think of it like 12 over 1, you're just going straight across. But again, when you're doing, you could just simplify, right? 6 goes into 12 how many times? 2. So that's 2t. Right? How is this one going to simplify? Right? You're going to multiply times like that and like that. So that's 0.4 times 3 plus 1.1c times 3. Okay, what's 3 times 0.4? What's 3 times 4? 12, right? But the fact that it's 0.4, 1.2. Remember when you do it, you go 0.4 times 3 is 12, and then because that's over 1 decimal place, then this is over 1 decimal place. So there's 1.2. And then 3 times 1.1c. What's 3 times 1.1? What's 3 times 11? 33. Move the decimal point over 1, right? So plus 3.3c. How about this one? right? That'll be 2y times negative y minus 1 times negative y. 2y times negative y, you know, a y times a y is y squared, right? It's not 2y, it's y squared. All right, we have 2y squared, and what's the sign of that? Because of the minus there, it's minus. And what's negative 1 times negative y? Negative times negative means plus. Right? That's just basic distributive property. Now, it could also be considered distributive property when you've got, you know, two terms in the numerator and a denominator, right? You break that up into two different fractions. That's like 1/5 times 7x plus 2, which is 1/5 times 7x plus 1/5 times 2, 7/5 x plus 2/5. I mean, really, I wouldn't even have done that. I would have just said that's 7x over 5 plus 2 over 5. You can just make that into two different fractions. What would the two fractions be here? 4x over 3 minus 16 over 3. Okay, how about this one? $11 over 6, yeah, plus 3x over 6. Now, can't you simplify that? The 3x over 6? 3 goes into 6 2 times, right? So this would be 11 over 6 plus 1/2 x, or x over 2, same thing. See, when you're looking at it here, if you looked at the 3 and the 6 and you thought, oh, I can simplify that, you got to be careful because you can't, right? Because the 11 would not simplify with the 6. You need to break it up into two fractions so you can simplify just the second fraction. You still had the 6 underneath the 11. How about this one? 15 plus 6x over 12. Plus 6x over 12. Now, both of those can be simplified. Not exactly the same way, though, right? What's in common between 15 and 12? 3, right? So how many 3's in 15? 5. And how many 3's in 12? 4. And then the 6x over 12, well, 6 goes into 12 twice. So this is just going to be x over 2. Now they got different denominators, but that's fine just because that's why you split it up, so you can simplify them the most. How about this one here? Right, and this one definitely looks like there's going to be some simplifying once we do this. What is the first one equal to? No, 1/2, right? Because the 8 is in the denominator, that's 1/2. And then the 2 over 8 is 1/4, right? The 2 goes into 8 4 times, minus x over 4. Okay. So multiplication property of -1. We saw this already as one of our properties. You know, what happens when you multiply by -1? It flips the sign. Whatever is the sign of it, it flips the sign. It makes it the opposite of what it started with. So this -a plus 5 is -a minus 5. Okay, what about when you distribute the minus on this one? Negative, parentheses, -x plus 3. The negative times negative makes positive. And negative times 31 makes minus 31. Could you write it like x plus -31? Sure, that's the definition of subtraction, is plus and negative. So yeah, that would be okay too. Either one would be fine. But just remember, when you multiply by negative, it flips the signs of every term inside. What about this one? Yeah, since that's a positive 4x and that's a negative 12, when you multiply by negative 1, flips the sign of both, negative 4x plus plus 12. And the second one, negative 6m plus 9n. Flip the sign of everything when you multiply by negative 1. Okay, now the last thing is, this is the section where it gets into combining like terms. So before you can combine like terms, we just have to make sure what we mean by terms, right? What are terms? Terms are separated by pluses and minuses for addition and subtraction, right? That negative, that is not a negative 5ab, like it's 6 times negative 5ab. That is a subtraction. So terms are separated by subtraction symbols and addition symbols. So something like this has how many terms? 1, 2, 3, 4 terms, right? The terms are made up of variables, represented by the letters, and coefficients. And the coefficients are the numbers that are in front. And we use these words all the time, like we know what they mean. We say, what is the coefficient of this term? 6. What is the coefficient? Negative 5. I mean, even over here when it wasn't written like plus and negative, if you said, what's the coefficient of that term? It's negative 5. And the last term, because there is no variable with it, you wouldn't call it a coefficient. It's just a constant. Since there's no variable, it doesn't change. It's constant. So once we know what that is, then we can talk about what do we mean by like terms. And this is not exactly the way that I use. They have the same variable raised to the same power, right? In this textbook, they say has the same variable factors. Okay, whatever. To me, it's the same variables raised to the same power. Like I can't add variables that don't have the same exponents. But if they do have the same, it's like this is a to the first and a to the first. Those are like terms. X squared and x squared, like terms. 6ab, negative 2a. Okay, well, it's missing the b in the second term. Those are not like terms, so you can't add them. And are these like terms, xy squared and x squared y? Are they exactly the same variables raised to exactly the same powers? The answer is no, right? In the first one, it's y squared, and the second one, it's x squared. So you cannot add those. They are not like terms. Right? If they are like terms, then you can add them by adding the coefficients. And you can see this one, the 8x squared plus 2x. And they're called, their reason for doing this, they're saying, is distributive property. But it's really kind of like a reverse distributive property. If you can see, they've taken the x squared outside parentheses, and now just the coefficients are left, 8 plus 2. You know, if I gave you that problem on a previous slide as a practice for distributive property, then you would have said 8 times x squared plus 2 times x squared. So it's really kind of a reverse distributive property. Bottom line is, because these are like terms, x squared, you add them by adding the coefficients. Right? 8x squared plus 2x squared is how many x squareds? 10x squareds. 8 apples plus 2 apples is 10 apples, and it doesn't change the exponent, right? Don't try to like add those up and make that a 4. It doesn't work like that. That's multiplying, not adding. So what are the like terms in this one? 5x minus 3x. What else is like terms? There's only one y term, but there's 2 constants. Those would be considered like terms. So you add what you can add. 5x minus 3x would be how many x's? 5 minus 3, 2 x's, right? Negative 3 plus 4, positive 1, right? So that's 2x plus 6y was unchanged plus 1. And you could see the way they did it here, that they actually did some, let's switch the order of these two so the x's are right next to each other. We don't normally do that, but they usually at the beginning they'll show you things like that. They actually moved these two to put them right next to each other too. And then they took out the coefficients, 5 minus 3, and over here we kept the negative 3 plus 4. Right? Can you simplify 3y minus y? Are they like terms? Do they have the same variables raised to the same power? Yes. Why? What power is it raised to? 1, because you don't see an exponent, you assume they mean 1, right? So how many y's would that be? 3y minus y. It's 2y, right? If you think of it like 3 minus 1 times y is 2y, right? There is an implied 1 also as the coefficient. If you don't see one there, there's a 1 there. Are these like terms? Let's see, they have mn to the 4th. Both of them are the same variables raised to the same powers. So how many mn's to the 4th do we have? Right, negative 7 minus 5 mn to the 4th, which is negative 12. And which terms can we add here, or can we add any of them? Yeah, that one and that one have y to the 3rd z, right? Not the same thing. The middle one is reverse the exponents, so we can't add those two. But how many y to the 3rd z's do we have there? Right? Because you don't see a coefficient there, that's a 1. So that's 7 plus 1, y to the 3rd z, minus 6y z to the 3rd, which is 8y to the 3rd z, minus 6y z to the 3rd. Now, could you do something to put those together? No. So just stop. Don't try to push it any further. So that's it. That's a distributive property, combining like terms. Homework is going to be in the workbook. These problems, if you want to write them down. Next class will be our review day before we take a test on Friday.